Hello guys, we're going to look at the metric system in this video. What you have here available on screen is a lot of information, but we're going to take it little by little and then we're going to go and do two examples together, and then I will give you guys time to work on three by yourselves and I provide the answer key at the very end. So right here what we have is a portion of the metric system. In our class we're going to mostly focus on the units that are going from mega all the way down to nano, okay? So if you're familiar with the words or with the prefixes, mega is pretty large, right? Where nano, when we're talking about something being nanos, like whatever unit, we're talking about something that's really, really tiny, right? So just keep this in mind that we're looking at very large units and very small units, okay? Something important here to note is that the base unit can either be gram, meter, and liter. Now that meter tends to give students a lot of issues because if you actually look at it, the letter M shows up 3 times. It shows up in mega, it shows up in the unit, and it shows in milli, okay? Do not confuse them. Mega will always show up with one of the base units. So it'll either be megagram, megameter, or megaliter, okay? The base unit for meter will always show up by itself, just M by itself, lowercase, okay? Now for milli, it will show with the same base units, but instead of being capitalized, it will be lowercase. So we're talking about milligram, millimeter, and milliliter, okay? So the capitalization of the letter M does matter, okay? Now we're going to follow 3 basic steps every time, okay? And what we're going to have here is going to be the T-chart. And I want to draw your attention to the very top of the screen. So where we have this large little T-chart, okay? What is given to you will always be provided on the problem. So on this top corner, we will always write what is given to us. It will be a unit and a number, okay? Now, here on the bottom, we're always going to bring down what is it that we want to cancel. So we only bring the unit, never the number. And then on top, we're going to write the unit that we want. And this also is a piece of information that will be given to you on the problem, okay? So if we look here in the example number 1, we are told that we are starting with 10 nanograms, right? All I'm doing is I'm looking at the unit and I'm saying, well, N is nano and G is gram, so nanogram, right? And we're being asked to convert it from nanograms to centigrams, right? So we look at the entire metric system itself. So on the top left corner, we wrote 10,000 nanograms because that's what it's given, right? We're referring back to that. Oh no, go back. We're referring back to the little sample that we have here on top. So we were given 10,000 nanograms. And if you notice here on the bottom, you are bringing down the NG, right? I didn't bring the number. If you notice, they're completely 2 different numbers. I'll explain to you in a moment where that 10 million comes from. And then on top, we wrote CG because CG is the new unit that we're being asked for, right? In that corner, in the right corner, we write what we want. So right now, that's what we have. Now, where did these numbers come from? Well, if you look at step number 2, it tells you that the unit that is larger gets the number 1. So if we compare the centigram, right, which is right here, and we compare that one to the nanogram, which is down, oh no, it keeps going back, to the nanogram, which of the 2 is larger, right? And we have these little squares to show like relative size. And we can see that the centigram is much larger, right? So centigram is it's a larger one, and for that reason we gave it a 1. Now for step number 3, it says to count the amount of jumps between the 2 units. That is how many zeros go with the smallest unit. And in your previous lecture that PowerPoint that you saw, you were told that the metric system is based on the base unit 10, right? So basically what we're saying is that centigram is 10 times larger than the milli. And milli is 10 times larger than the next unit, and so forth, and so forth, and so forth, and so forth, right? So if we count the steps, we would see that we have 1, 2, 3, 4, 5, 6, 7 steps. So if each of them is larger than the next by a magnitude of 10, you could do 10 times 10 times 10 times 10, 7 times, right? And you would end up with the number 10 million. But if you're really good at math, you might remember the trick where if you're multiplying 10 by itself, all you have to do is count the zeros, right? So if we multiply 10 to itself 7 times, it would result with the number of 7 zeros, right? So that's the reason we have this number in the bottom, 10 million. And that's just, instead of having to do 10 times 10 times 10, so forth, 7 times, you could just use that trick, right? So anyway, whenever we have this already set up, all you have to do is take your two numbers on the top and multiply them. And that number you get, you divide it by the number that's at the bottom. So we would do 10,000 times 1, which would give us 10,000, and then divide that number by 10 million. And when we do so, we would end up with the value 0.001 centigrams. Okay, so that's our first example. We're going to look at example number 2. I just need to figure out how to erase this, and I forgot. No, I don't remember the commands for this. It's okay. So on example number 2, we are going to go from 0.0003 megameters to meters, right? So we're going from the mega all the way down to the meter, right? And I know it's a meter because remember, I told you guys, meter, when it's an M lowercase by itself, we're talking about meter. Don't go all the way to milli because milli would have been two M's, right? So same idea. We write down what it's given to us on the left corner. We bring down those units, right? Megameter, and then on top the unit that we want. Then we look on step number 2, which one of the two is larger? We can see that the mega is larger than the meter, so therefore the mega gets the 1. And then what we have on top is how many jumps there are. So we count the jumps, right? But really, we're not talking about just jumps. We're talking about orders of magnitude. We're talking about every time there's a jump, there's a multiplication of 10 by itself, right? So we're talking about mega being 1, 2, 3, 4, 5, 6 steps away from meter, which is why we have a total of 6 zeros here for the million, right? Because 10 times 10 times 10, 6 times is a million. So then we're going to take the two numbers on top, multiply them. So 0.0003 times 1 million divided by 1 gives us 300 meters. And those are our conversions, right? So now we're going to move on and we're going to do 2 more examples. I'll do these pretty quick. So here we have different values, right? On the first example, we have 8,920 grams. So that's what I'm going to write, 8,920 grams. And that's what's given to me. I'm going to bring down my units of grams because I'm going to cancel them. And then on top, I'm writing the units that I want. And the question's telling me to look for megagrams. So that's what I'm going to write. So we have our setup. Step number 2, if you remember, is to give one of these two units a 1, whichever one is larger. So we're comparing the mega to the gram, right, which is right here. So which one's larger, the mega? And then last step to setting up is counting how many jumps we are making. So we have 1, 2, 3, 4, 5, 6. A total of 6 steps. So 10 times 10 times 10, a total of 6 times. Or we could just say that is a total of, okay, those are not 6. They're supposed to be 0, guys. But my screen is not catching them as zeros. So 1 million, okay? I'm going to write it right here. 1 million, because I feel like students are going to get confused. So now that we have this set up, we're going to use a calculator, and we're going to take 8,920 multiplied by 1, but we know it's going to give us the same number, and then divide that by 1 million. 1, 2, 3, 4, 5, 6 zeros, perfect. And my answer comes out to be 0.0892 megagrams. So that would be our answer for this question. For the next example that we have, we start with 456,000 centimeters, right? We bring down our units to cancel. On top, we write the ones we're being asked for, which in this scenario is kilometer. Okay. Now, if you remember from the previous slide, the 1 doesn't always go in the front. Sometimes it can go in the, not in the front, in the top. Sometimes it can go in the bottom, right? It's like right down here. So we'll see whenever that happens, okay? Don't memorize 1 always goes on top or always goes on bottom. It always goes with whoever is larger. And here we're talking about kilometers and centimeters. So let's compare the two. Kilo versus centi, which one's larger, which one's closer to the mega? The kilo. So that's the reason where we're giving the kilometer the 1, not because it's on top, but because it happens to be the one that we're comparing that is larger in size, okay? So centimeter then is how many steps away from kilo. So that would be 1, 2, 3, 4, 5. So 10 times 10 times 10 times 10 times 10, 5 times would give us the following number. That would be 1, 2, 3, 4, 5, 100,000, okay? So those are the values that we have in our dimensional analysis chart, okay? So again, just like before, we are going to take the two numbers on the top and multiply them. So 456,000 times 1 gives us the same number. And then we're going to take that number and divide it by 100,000. And that comes out to be 4.56 kilometers, right? So that's my answer for the second one. This one was my answer for the first one. All right. Now here you guys have a total of 3 examples. On the next slide, you guys can actually see the setup and the answer key. It's a lot cleaner than the ones that I just showed you guys because I was writing on the screen. But please take a moment, pause the video, work on these 3 by yourselves. You will need to go back and look at the metric system conversions that we have here. So if I were you, I would either take a picture of it or write it down because we're going to be using it pretty often. And then go ahead and get started with these 3, pause the video, and then come back to look at the setup and the answer key that's on the next slide. All right, guys, hopefully you were able to get these 3 correct. If not, part of your assignment for today will be to work on some extra examples that are posted on Schoology. We will also then afterwards look at the answer key that has also been provided.